All right, people. I believe everybody is doing great, nice, and absolutely fine. Let me know in the chats if I'm perfectly audible and visible to each and every one. Okay. Welcome to Phoenix 2.0 and welcome to Unacademy NEET English. If you have not liked the session yet, I want you guys to like it as soon as possible because liking the session is mandatory. Everybody out there, smash the like button, guys. Just a second. Okay. Just a second. Okay. So I am live, I guess, perfectly audible and visible. Let me know in the live chat if I am perfectly audible and visible. Okay. Let me fix up everything over here in my studio because I need to see your chats also. So that's mandatory. That's the reason I'm setting up everything over here. Okay, great. So guys, tell me in the chats if I am, and if you have not liked the session yet, I want you guys to like the session as soon as possible because liking the session is mandatory because so this is the first session of Phoenix 2.0 which is completely free of cost. Okay. And free of cost means this session is free of cost. Okay. If you have not joined this session yet, I suggest you guys to join it as soon as possible. Okay. That's mandatory. Because if you want to learn everything from scratch, we say this session is definitely for you. We say this session is definitely for you. Just a second, people. Just a second. Let the people join and we are starting accordingly. So, in this session, live session, first session of Phoenix 2.0, first plus live class on YouTube, we will be starting the chapter that is electrostatics. Okay, because electrostatics is the high weightage chapter. That's the reason I take electrostatics over here. Okay, so I will be starting from the scratch. I'll be starting from the basics. If you haven't studied this chapter before, I'm 110% sure you will be able to understand every single point because I will be taking you from the scratch, from the basics, and I will take you to the level which you actually need in order to solve all the problems of your NEET examination, Okay, so guys, I think we need to start now. And if you have not liked the session yet, I want you guys to like this session as soon as possible. That's mandatory. Okay. Hit the like button. Now, guys, listen to me very carefully. Now, see. Let me just tell you over here. In this particular session, since this is the first session, we will be talking about, we say the chapter that is electrostatics. Okay. Guys, see, when it comes to the chapter electrostatics, we say here, we say charges. I have got a charge over here. We'll say, sir, it will create electric field. I have got a charge over here. It will apply the force on another charge. Like in kinematics before, if you remember, in kinematics chapter, we used to talk about, sir, we have a car over here, okay? This car is in motion. We say how much displacement it will cover. We say what is the velocity of the car. We say what is the acceleration of the car. These are the points we discuss in, we say, kinematics. We basically talk about motion over here. Similarly, in laws of motion, we used to discuss about the forces. But since we are talking about the electrostatics, guys, listen to me very carefully. We will be talking about, sir, the first topic, that is electric charge. Electric charge. Okay. So here we will be discussing about the electric charges. That's what electrostatics is all about. Here we will be discussing, we say electric charge. Everything we'll be discussing about electric charge. Like charge creates electric field. Okay. Charge will apply force on another charge. So first topic over here that we need to understand is electric charge. Sir, what is this charge? Let's understand this charge first. Let's suppose I'll take a comb over here. This is the comb that I'm taking over here. This is a comb, okay, with which we make hair. And I'll place the small piece of papers over here. Small piece of papers. Okay. This is a comb, and these are the small piece of papers over here in front of me. Okay. Okay, small piece of papers over here in front of me. Now, my dear friends, I'm asking you to rub this comb with your hair. When you rub the comb with your hair, and then you take this piece of paper, then you take this comb near to the piece of paper, could you please tell me what's going to happen? We say, sir, these will be attracted. These will be attracted and they will stick to the comb. These will be attracted and they will stick to the comb. So we say attraction will be here. Okay, this attraction will take place. So I'm saying that when we rub the comb with my hair, then if I take it to the near to the piece of papers, we say it will be attracted towards the comb. So before rubbing the comb with my hair, or even pen, before rubbing this comb with my hair, if I take it near to the piece of papers, no attraction will be there. These piece of papers will not be attracted towards the comb. So I say, after you rub, then only these piece of papers will be attracted to the comb. So what has happened actually over here? We say when you rub the comb with your hair, something gets occupied onto this comb. Something gets transferred onto this comb. When you rub the comb with your hair, something gets transferred from your hair to the comb. And that something is what we call electric charge. That something is what we call electric charge. So my dear friends, when you rub the comb with your hair, we say the comb gets charged. Charge comes onto the comb. And because of that charge, we say these piece of papers are attracted towards the comb. So can I say, I'll write over here, charge is something, or charge is an intrinsic property. Charge is something. Charge is something. We say due to which a body shows electrical and magnetic effects. So we say charge is something due to which a body shows electrical and magnetic effects. Sir, what does magnetic effects mean? Magnetic effects over here, this attraction. This is what we call magnetic. What are electrical effects? Sir, when the charge flows, current will be produced. That we'll talk about after some time. So here we say it is because of the charge only this magnetic effect, this attraction takes place. So we say it is because of the charge. Okay. Now, my dear friends, listen to me very carefully. When it comes to the types of charge, everybody over here, listen to me very carefully. We have got two types of charge. We say one is positive charge and other is, we say, sir, negative charge. Other is negative charge. Positive charge and negative charge. There are two types of charge. We say positive and negative charge. Now, my dear friends, if I say, let's suppose, I place the positive charge over here, and I place one more positive charge over here. Remember, if you place the two positive charges close to each other, we say they will repel each other. So this will repel this and this will repel this. So we say like charges repel each other. Even if you place negative charge, even if you place another negative charge, they will also repel each other. Why? Because negative will also repel, like charges repel. And if you place over here positive, if you place over here negative, we say they will attract. Why? Because we say positive, negative attracts. Positive, negative attracts. Let me write over here. We say like charges repel, and then we say unlike charges, we say attract. Unlike charges attract. Like charges repel and unlike charges attract. Guys, tell me over here. Tell me over here. Is this crystalline clear to each and everyone? Is this crystalline clear to each and everyone? Let me know in the chats if this is crystalline clear to each and everyone. Is this crystalline clear? In the chats, everybody. Everybody in the chats. Guys, let me know. If you have not liked the session yet, guys, I want you guys to like this session, okay? Everybody out there, like this session as soon as possible. Liking the session is mandatory. Okay? Now, guys, now, when we talk about symbol of charge. Symbol of charge. We say, sir, symbol of charge is simply that is Q. What does that mean? Like, if I say I have got a block over here, okay? I say mass of this block is, we say, sir, 2 kgs. We write over here M is equal to 2 kgs. M means the mass of the block. M is, we say, the symbol of mass. Well, we represent mass with M. Similarly, when it comes to the charge, the symbol of charge is Q. If I say I have got the rod over here, on this rod, we say Q is equal to, we say, sir, plus 2 coulomb charge. We do not say M is equal to 2 coulomb charge. We say Q, symbol of charge is Q. And when it comes to, my dear friends, SI unit of charge, we say SI unit of charge is, we say, sir, coulomb. Okay, that is C. So we say, sir, Q is equal to 2 coulomb charge over here. Like we say SI unit of mass is, we say kg over here. So we measure this mass in kgs. Similarly, we measure the charge in coulombs, 2 coulomb charge, 3 coulomb charge, 10 coulomb charge. So we say. So simply SI unit of charge is coulomb. Okay, we say I have got one more rod over here. On this rod, you have got, let's suppose Q is equal to, we say 10 coulomb charge. You do not say 10 kg charge, 10 coulomb charge. Okay. So this was the information about the charge. This was the information about the charge. Now listen to me very carefully. Now let's talk about positively charged body. Positively charged body. Okay. Let's talk about positively charged body. What does a positively charged body actually mean? Listen to me very carefully. Guys, remember one thing. If we talk about an atom, let's suppose I say, if we talk about an atom, if I ask you to draw the atom on the screen over here, if I ask you to draw the atom on the screen, what will you say? Sir, the center of the atom, at the center of the atom, it has got nucleus. And around the nucleus, this is nucleus. Around the nucleus, we say electrons are revolving. This is how do we actually make the atom. And my dear friends, when it comes to the nucleus, nucleus has got protons in it and it has got neutrons in it. I want you guys to remember one thing. What is that? If we talk about the proton, we say, sir, proton has got positive charge. Remember, proton is that particle which lies inside the nucleus. Neutron is that particle which lies inside the nucleus. So we say proton has got positive charge. And when it comes to the electron, we say electron has got, we say, negative charge. And when it comes to the neutron, we say neutron is, we say, neutral. Okay, neutron is neutral. Now, my dear friends, let's suppose if I make the atom over here. Let's suppose if I make the atom over here. Let's suppose if I make the atom over here. This is the nucleus, okay? And then we say around the nucleus, we say this is, let's suppose, first orbit, and this is, let's suppose, second orbit. This is, let's suppose, second orbit. Sir, what is this orbit? Orbit means in which electron is revolving. So we say inside the nucleus, we have, let's suppose, got 4 protons and 4 neutrons. Because I told you, when it comes to an atom is made up of nucleus, electrons revolving around the nucleus. Inside the nucleus, you have got 4 protons, 4 neutrons. And we say here, 1, 2, 3, and 4 electrons are revolving around the nucleus. 4 electrons. If I ask you the simple question in this particular case, can you tell me the number of negative charges over here? You say, sir, number of negative charges are 1, 2, 3, 4. Why? Because electron has got negative charge. So we say, and how many number of positive charges? We say, sir, 4. Why? Because it has got 4 protons. 4 protons has got 4 positive charge. So I can say in this particular case, number of negative charge is equal to, I say, number of positive charges. So when number of negative charge is equal to the number of positive charge, remember in that case, we say the body is neutral. Okay. And in this particular case, I can say net charge is 0. In this particular case, I can say net charge is 0. When number of negative charge is equal to the amount of positive charge on a body, we say that body is neutral and net charge is 0. Now I want you guys to do one thing in this particular case. I want you guys to remove one electron. I want you guys to remove one electron from this. If you remove one electron, can I make the same figure? Can I make the same figure over here? Can I make the same figure over here? See, I'll make, this is the nucleus. This is the electron revolving around the nucleus. This is the first orbit, let's suppose. Okay. And let's suppose this is the second orbit over here. Now, my dear friends, inside the nucleus, how many protons are there? We say, sir, 4 protons. How many neutrons are there? We say, sir, 4 neutrons. Okay. Now, if you are removing one electron, how many electrons will remain? Sir, in the first orbit, you have got 1 and 2, this and this. In the second orbit, you have got only 1. Can I say in this particular case, we say, sir, number of negative charges is less than number of positive charges. We can clearly see it. Number of negative charges less than number of positive charges. So I can say when number of negative charges becomes less than number of positive charge, we say net charge in this case is, we say, sir, positive. So we can also say this body is positively charged. So means from now onwards, you'll remember that if you remove the electron, if you remove the negative charge from any body, we say it becomes positively charged. Or if you say number of positive charge becomes greater than number of negative charge, we say this is what we call the positively charged body. Similarly, if I ask you to make the negatively charged body, if I ask you to make the negatively charged body, okay, listen to me very, very, very carefully. When it comes to the negatively charged body, let me make the same atom over here. This is the nucleus. Around the nucleus, you have got the electrons revolving. Okay. This is the first orbit and second orbit. Now, my dear friends, you have got 4 protons, you have got 4 neutrons. This is 1 electron, second electron, third electron, and 4 electron. Now, you have to make this body negatively charged. What you are supposed to do in that case, I say you supply 1 electron. By means of something, you are supplying 1 electron over here. So when you supply 1 electron, if I make the atom over here, listen to me very carefully. Can I say afterwards it will look something like this? This is 4 protons, 4 neutrons. 1 electron, another electron, 1 more electron, 1 more electron, and 1 more electron. Now here, you tell me one thing. Sir, initially net charge in this case is 0. Why? Because amount of negative charge is equal to amount of positive charge. 4 protons, 4 electrons. But when it comes to over here, can I say number of negative charges is greater than, we say, number of, we say, positive charges. number of negative charge is greater than number of positive charges. Okay, okay. So we say when negative charge becomes greater than positive charge, we say this becomes negatively charged. This becomes negatively charged. As simple as that. So my dear friends, if you want to make anybody negatively charged, you have to send the electron. If you want to make anybody positively charged, you have to take out the electron. Okay. Is this clear till over here? Let me know in the chats, is this clear till over here, everybody? Okay, great, 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 great. Now, let's talk about the properties of charge. Let's talk about the properties of charge. Let's talk about the properties of charge. Properties of charge. Let's talk about the properties of charge. My dear friends, when it comes to the properties of charge, the first is we say charge is a scalar quantity. We say charge is a scalar quantity. Scalar quantity means which has only magnitude, which does not have the direction. This is what we call the scalar quantity. That quantity which has got only magnitude, no direction at all. Okay. Now the second property, if we just write over here, that is, we say charge is conserved. Second property over here is charge is conserved. Sir, what does conservation of charge mean? Let's suppose, my dear friends, when it comes to the conservation of charge, let's suppose I'm taking a box over here. This is the box that I'm taking in this particular case. Okay. And inside this box, I have taken few balls or few spheres. Okay. Like we have got this sphere. We have got one more sphere. We have got one more sphere. Now, in this box or in this sphere, we have got +1 coulomb charge. Here we have got +2 coulomb charge. And here we have got +6 coulomb of charge. Can you tell me how much is the net charge inside this box? You say, sir, when it comes to the net charge, you say, sir, 6 + 2 is 8 plus, that is +9 coulomb. Now, I want you guys to take this box, okay? Take it to some other place, shake it, okay? Throw it somewhere else. And after that, you bring it back and then place it over here. After that, you bring it back and then place it over here. The same box, okay? Now, my dear friends, when you open this box, so you have got one ball, you have got second ball, and you have got third ball. You saw that in this first ball, it is +2 coulomb charge. How much was the charge initially? That is +1 coulomb charge. In this ball, you have got 4 coulomb charge. How much was the charge initially? In the second ball, we say +2 coulomb. And here in this ball, we say you have got +3 coulomb charge. How much was the charge initially? +6 coulomb. Now, if I ask you, could you please tell me how much is the net charge over here? You say, sir, net charge is 3. 4 + 3 is 7. 7 + 2 is 9. So we say that is +9 coulomb. Can I say in this particular case, the charge initially is equal to the charge finally? Charge initially is equal to the charge finally. Sir, the charge initially before is equal to the charge finally. But when it comes to the inside balls, we say charge is different. So my dear friends, what I'm trying to say in this particular case is that, charge can neither be created nor be destroyed. See, charge remains conserved. Charge remains conserved, +9 +9. Charge can neither be created nor be destroyed, but can be transferred from one body to another. Internally, they are sharing the charge with each other, but as a whole, charge remains conserved. Because charge initial is equal to charge final. Internally, they are sharing the charge, transferring the charge, but as a whole, the charge remains conserved. Second property is we say charge is quantized. Charge is quantized. What does quantization of charge mean? It means that charge is available in, we say, fixed amounts. We say charge is available in fixed amounts. That's what we call the quantization of charge. That's what we call the quantization of charge. Okay. Now, my dear friends, listen to me very carefully. How do we exactly define the quantization? Charge is available in fixed amounts. What does that mean? What does that mean? See. I'll tell you. Let's suppose I have got the shop 1 over here. This shop is selling the cricket balls. Okay. And I went to the shopkeeper. I asked him, give me the smallest ball. That is possible. He said, take this one. I said, no, give me the smallest, then smaller than this one. He said, then take this one. This is the smaller one. I said, no, give me the smaller than this one. He said, take this one. I said, no, smaller than this one. He said, then take this one. I said, no, smaller than this one. He said, take this one. I said, smaller than, sorry. I said, smaller than this one. He said, this is the smallest ball possible. This is the smallest ball company is making. So you cannot get smaller ball than this in the entire world. So this is the smallest one. Okay. Now, my dear friends, if I go to the shop 2, I have got over here, that is shop 2. And this shop 2 is basically selling charge. Okay, this is selling balls and this is selling charge. And I asked this shopkeeper that give me the smallest charge that exists in your shop. He said, take this one. I said, no, smaller than this one. I said, give me small. He said, take this one. I said, no, smaller than this one. He said, then take this one. I said, no, smaller than this one. This one. Sir, this one. So I asked him, give me the smaller charge than this. So he said, sir, this is the smallest charge. Smallest charge possible. This is the smallest charge possible. If I ask him, my dear friends, listen to me very carefully. If I ask him, give me the smaller than this one. He said, no, this is the smallest charge which exists. And how much is this charge? And this is the charge on 1 electron. And how much is charge on 1 electron? That is 1.6 into 10 raised power minus 19 coulomb. So this is the smallest charge that exists in the world. So my dear friends, what I'm trying to say is that 1 electron is the smallest charge that exists in the world. If I ask you to get me E by 2, half of the electron, is it possible? No, sir, this charge is not possible. Why? Because this is the smallest. If I ask you to get me 2 electrons, is it possible? Yes. 1 plus 1 is 2. If I ask you to get me 2.5 electrons, is it possible? No. Why? 2 electrons you can bring, but you cannot bring 2.5 electrons. We say, sir, 3 electrons you can bring, you cannot get 3.75 electrons. Similarly, 4 electrons and so on, we say n electrons. Can I write over here, these are the charges possible. These are the charges possible. And we say, these are the charges which are not possible. Just a second, guys. We say these are the charges which are not possible. These are the charges which are possible. Okay. Now, can I say in this particular case, we say, sir, charge is available in fixed amounts only. Means charge is available in these amounts only. You cannot bring 0.5 electron, 2.5 electron. So that's why we say charge is available in fixed amounts. Charge is quantized. Quantized means available in fixed amounts. Okay. So we say what is the charge possible? Q is equal to plus minus n times of E, where this n is an integer. Okay. 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. Like if I say, let's suppose you go to the shopkeeper, you ask him, give me 1 pen. He say, I'll take 1 pen. You ask him, give me 2 pens. He can give you 2 pens. You ask him, give me 2.5 pens. You'll say, sir, 2.5 pens are not possible. Why? Because 2 pens you can bring, but 2.5 pen is not possible. He can't break the pen and give it to you. Okay. So we say pens are available in fixed amounts. Okay, but if you go to the shop and you ask him, give me 1 kg of rice, he can give you. Give me 0.5 kg of rice, he can give you. Give me 7 kg of rice, he can give you. He can give you rice in any amount. So means rice is available in random amounts, but charge is available in fixed amounts. And charge is available in plus minus n times of E, where n is an integer and E is the charge on 1 electron. E is the charge on 1 electron. I hope this is clear. Now, my dear friends, what if I ask you the question over here on the quantization of charge? That is, calculate the number of electrons in 1 coulomb of charge. I am asking you, if let's suppose we are getting 1 coulomb of charge, how many electrons are present in 1 coulomb of charge? That's what we need to discuss. See. We say we have the formula Q is equal to plus minus n times of E. This is the formula. Can I say over here, sir, n is equal to Q divided by E? Yes. We are supposed to find the value of n. How many number of electrons are in 1 coulomb? So what is the value of Q in this case? Q is 1 coulomb. So this is 1 upon. What is the charge on 1 electron? Charge on 1 electron is 1.6 into 10 raised power minus 19 coulomb. So it will be 1.6 into 10 raised power minus 19. Okay. So I can say this n will be 1 divided by 1.6 is 0.625 into 10 raised power. We say if you take it in the numerator, it will be 10 raised power plus 19. So n is equal to 6.25 into 10 raised power, we say, sir, 18. So these many number of electrons are present in, we say, 1 coulomb of charge. Okay. Next, if I ask you the question, can a charge of 8 into 10 raised power minus 18 coulomb be given to a body? Can a charge of this much be given to a body? Means if you have got this much of charge, can this charge actually exist? How do we check? Let me tell you. We say, sir, Q is equal to n times of E. We say n is equal to Q divided by E. What is the value of Q? Q in this case is 8 into 10 raised power minus 18 divided by charge on 1 electron is 1.6 into 10 raised power minus 19. 8 divided by 1.6 is 5 into 10 raised power minus 18 divided by 10 raised power minus 19. If you take this in the numerator, so this will be 5 into 10 raised power minus 18 into 10 raised power 19 plus 19. So plus 19 minus 18 is 10 raised power 1. So this will be 5 into 10. So that will be, sir, 50. So in this case, n is an integer. So if value of n comes out to be integer, means yes, this amount of charge can be given to a body. This amount of charge exists in the world. Okay, this amount of charge exists in the world. Okay. Is this crystalline clear, guys? Is this crystalline clear? Is this crystalline clear? Next we have got over here. Listen to me very carefully. That is, we say charges are relativistically invariant. Sir, what does this mean? Charges are relativistically invariant. What does this mean actually? See, let's suppose I say I have got a mass m over here. Okay. And this mass m comes in motion. It starts moving with some speed. We say whenever mass comes in motion, we say its mass changes. Okay. If let's suppose I have got an object, it comes in motion, we say its mass changes. Okay. And how can we find the value of that mass? We say it is equal to m naught by under root of 1 minus v square divided by c square. This is the formula by which we can find the mass of that body. This is mass in motion. And this is what we call a rest mass. Mass, when the body is at rest, this is the rest mass. But when it comes to the charge, my dear friends, let's suppose you have got a charge over here. Okay. And this charge is, let's suppose over here 1 coulomb charge. At rest, it is 1 coulomb. Now, if this 1 coulomb charge starts moving, okay, it's now in motion. We say its charge here, if I say Q is equal to 1 coulomb, so here Q dash is also equal to 1 coulomb. We say charges are relativistic invariant. If charges move with some speed, nothing is going to happen to its magnitude. It will remain 1 coulomb only. Okay, so these are the properties of the charge. Next topic here we discuss, that is charging a body. Like there are different methods by which we can charge a body. Charging by conduction, charging by induction, charging by we say friction. So as of today in this class, we say thank you. Okay, I hope you liked the class. Let me know in the comments down below how was the class, each and every single thing. Let me know in the comments down below how was the class. Okay, so I guess this is all for today. Thank you so much, guys. Okay, and if you guys haven't joined the batch as of now, okay, I want you guys to join this batch as soon as possible. That is Phoenix 2.0, where we will be teaching you the complete syllabus. I'll be teaching the complete physics. Wasim sir and HSP sir will be teaching the complete chemistry. Ambika ma'am and Pankhuri ma'am will be teaching complete biology. And this batch is just for 5,499 rupees. Even you'll get the plus subscription, means you can have the access to all the batches. Okay. And how can you? The link is in the description below. You can click onto that link. Okay, and you will land onto this page. You can buy the subscription for 12 months also, 18 months also. So for 5,499 rupees, you will get it for 12 months. For, we say 24 months, you'll get it for 10,999. And it will ask for a code. You can use my code YAWAR and you'll get the maximum possible discount. Use this code only. Okay. So take care and bye-bye, my dear friends. This was all about it. Hope you liked the session. Okay. I hope. Do comment afterwards once I end the session. Take care and bye-bye. Thank you so much. Thank you so much.